Hello, this is Tim Lloyd from GMAT.cz, part of Gain Access in Prague, capital city of the Czech Republic, a beautiful part of Europe. This is the next question in our GMAT assessment test explanation video set, and this involves finding a square root minus a square root. Now, GMAT is a little bit obsessed with what we call squares and prime factorization, and associated with that, divisibility rules. This particular video is going to focus on the actual divisibility rule for the number 3. Okay, so the number I chose here was 567 for this question, first of all, because the rule is when you add together the units, the hundreds, etc., and you add those digits, if you get a multiple of 3, then the number itself is a multiple of 3. So 5 plus 6 plus 7 is 18. 18 is divisible by 3, you all know that. You do the long division. You better get good at this kind of stuff, guys, because in GMAT there's no calculator, so mental math and fast calculations such as long division must become second nature. So 567 divided by 3 is 189. Thank you for that, Tim. Okay, again, 1 plus... Okay, remember guys, we're looking for squares, which is the end goal of this process. We want to know, for example, how many 3's there are in 567. So again, we can divide 189 by 3. The reason being 1 plus 8 plus 9 is 18. Again, we know that's divisible by 3. When we go back to the start of this, we wouldn't divide 567 by 2 because it's not even. Okay. So we're just slowly progressing through the prime numbers, and I recommend starting with the small ones. So 189 divided by 3 is 63. Clearly divisible by 3 itself, because 6 is divisible by 3, as is 3. So 63 divided by 3. Hopefully Tim will move the board in a second. Okay, is 21. Now, if you know your times tables, immediately you know that 21 is 3 times 7. And remember, 7 itself is a prime factor, so we can go no further. Thank you, Tim, that's good. So we can now rewrite, after prime factorizing the number 567, we can rewrite that number as 3 times 3 times 3 times 3 times 7. Okay, I would imagine most of you did this when you were a lot younger at high school, but hey, we need to drag these skills back out, go through some books, a ton of practice material, and you'll be ready for your GMAT. Now we therefore can now rewrite 567 as 3 to the power 4 multiplied by 7. Remember, we use dots sometimes to represent multiply if it's at the bottom of the numbers. Expanding this now, we have 3 to the power 4 under the root multiplied by 7. Okay, so we extract the 3 to the power 4 and we divide the power by 2. So 3 to the 4 becomes 3 to the power 2. In case you're interested, that would be 81 inside the square root and 9 outside the square root. The root 7 stays as root 7 because prime numbers by themselves, when raised to an odd power, cannot be square rooted. It's that simple. Now the answer choices lend themselves towards the possibility of there being some kind of square root remaining. Now the next number we chose for this question was 486. Again, clearly divisible by 3 because 4 plus 8 is 12, plus 6 is 18. If you wanted to, you could have divided this by 6 because 486 is an even number and divisible by 3. Okay, but I chose not to do that so that we could just go step by step, and you can see how these numbers are easily broken down. Developing the skill, 162 divided by 3, 16 divided by 3 is 5, remainder 1, carry it to the 2, so then 12 divided by 3 is 4, 162 divided by 3, 54. Again, 5 and 4 adds to 9, therefore it's a multiple of 3. 54 divided by 3 is 18, and as we know, 3 times 6 is 18. which breaks down to 2 and 3. So again, we have a bunch of 3's, and this time the other prime factor is a 2. So the next step is carefully we rewrite 486 in terms of these prime factors, and we establish what power, in this case a 3, is being raised to, and then choose one that can be square rooted. In other words, we choose the even powers of any of our prime factors. There we go, thank you Tim. We want to square root them, so we need squares. So 3 to the power 4 is a square. If you know it as a number, it's 81. But what we're going to do now is, again, follow the same process as with the previous number. So 486 square rooted is 3 to the power 4 times 6. I'm leaving the 3 and the 2 in there because the other 3 is just raised to the 1. Odd powers cannot be square rooted. Okay, so the next step, as before, we remove 3 to the 4, and the square root of 3 to the 4 is 3 to the 2, and the square root of 6 cannot be reduced, and the answer choice, as I say, lends itself towards leaving that as it is, or the possible answer choice. So let's combine them, okay? And my instinct was initially that, wow, hold on a second, answer choice C looks pretty good. So let's see how this goes. We have, if you could move the camera, Tim. I'm actually talking to myself, but nothing will be there. So 3 squared to the 7 minus 3 squared to the, 3 squared times the square root of 7 minus 3 squared times the square root of 6. They share a common term, which is 3 squared. That means you can factor that common term out, and you end up with 3 squared root 7. Okay, but the root 7 moves into the bracket with the root 6. Okay, so pause and think about that if you need to, but the final answer now is very simply, because we can factor out the 3 squared, 9, parenthesis, root 7 minus root 6, so C was indeed correct. So I chose those numbers to illustrate various issues with prime factorization. Rewatch it if you need to. Contact me with any questions, and please go ahead and have a look at the next video for the next explanation from the GMAT.CZ assessment.